This is the second video in the structural checking of certain timber members, which I've called 2, surprisingly enough. And it's a follow-on from the floor joist, so we're still on floor joist, and this time we're going to support a partition over the top of multiple floor joists. So the partition is running in the same direction as the floor joist. This is a typical detail of how it all happens. Multiple joists will be located underneath the partition, and they tend to be decked over these days. If it's a treble joist, then you could probably put a plate on top, and there's some room to fix the floor decking. But this is probably a more airtight construction anyway, and there's no reason why you can't put the plate on top of the decking. It's just a matter of making sure that it hits, so it becomes a little bit more accurate to ascertain that plate is actually located over the multiple joist. The stud partitions, just standard stud partition, 4x2s or 3x2s with plasterboard either side, and in this case it's 2.4 meters high, 2,400 high, and we're going to stick with the clear span of the joist at 3.8 meters, which gives us 3.9 meters effective span, because that's what we're working at. I've skipped the start of the spreadsheet, but remember the first thing you need to do is to clear all the entries. Make sure that you're not bringing in data from a previous job. That's the most important. The rest is simple and straightforward. We'll do the internal partition first. That's down at cell 132, but you can scroll down until you find it. There's no reason why this couldn't be a blockwork partition. It's a habit that seems to have diminished over the years, but 20-30 years ago it was quite normal for the first floor partitions to be lightweight blockwork, aerated concrete blockwork, and built off multiple floor joists. And there's no reason for that not to start up again. So we've got lightweight partition, 100x50 studs with 12.5 millimeter plasterboard either side with some insulation. That gives a permanent load of 41 kilograms a square meter when you add it all up, and that equates to 0.4 of a kilonewton a square meter. Remember how we achieved that 41 to 0.4. It's 41 times 9.81, which is acceleration due to gravity, and divide that by 1,000, and that comes out at 0.4 of a kilonewton. And of course our unit area is meters squared. So we place, the partition's 2.4 meters high, and we place that 2.4 in the attributed load. So the load on the per meter of the beam is 2.4 times 0.4, and that's key. But as time goes on, you'll pick all of this lot up. On the right hand side is the floor construction. It's just changed it a little bit from the previous one. We've gone 18mm chipboard. We've gone cheap on this job. The other job was 15mm tongue and groove boarding, but we've gone a bit cheaper on this job. And we've got a couple of layers of plasterboard there because it's a full half-hour floor. It may be over a garage. Total load on that one's 58 kilograms a square meter, which equates to 0.57. So 58 times 9.81 divided by 1,000. There you go, 0.57. Domestic variable load, we discussed that a lot in the last video. That is for domestic properties 1.5. I should also put that on future videos. We're going to call that QA, because that helps you in Eurobeam. We'll stick with the centres, those unusual centres of 0.6 for the floor joists, and that would finish that particular part of the spreadsheet. after this, then you would press the single UDL, which corresponds to the same colour as the attributed load. And then you will have this sheet. Remember the yellow button and the little vertical trumpet or whatever it is that icon depicts. Press that and you will get that dialog box which I said before. Select all and X, and that will remove all irrelevant data. I'm not saying it will have irrelevant data on, but if it does, then that's a way to shift it. And there's the tabulation of the loads. Now they're turned into actions. Remember, a permanent load multiplied by a distance, it gives an action because that action's been applied to the beam. So we have floor construction on where we've got 0.6, 2 0.6s, one for the permanent, one for the variable, and multiplied by their corresponding values. And the internal wall, only permanent action, no variable action on that, and that gives a total permanent action of 1.31 kilonewtons a meter, and the total variable 0.9. And this is basically what we put into Eurobeam. So our start point again is the blank screen. We pop into our spreadsheet, opens up our loading spreadsheet, clear all the entries so nothing's contaminated, down to the floor. We said we go 18mm chipboard, 2 layers of plasterboard because it was a full half-hour floor, and our joist centres were at 600 centres, so that's the attributed load. And we move down to the lightweight stud partition, and we're going to have 1 layer of plasterboard on each side. And the partition is going to be 2.1 meters, 2.4 meters high. So that's the load aspect of it sorted. So now we move on to the single UDR. And like I said, just get into this habit of opening it up and then clearing it. And there's our tidied up UDL calculation. As you can see, there's the floor construction, permanent action of the floor and variable action of the floor, both 600 centres. And there's the permanent load, there's the variable load, and there's the permanent action and the variable action. And the internal wall is just permanent, just dead load in old money. There's no imposed load on the internal partition. So there it is, 2.4 meters high, and it weighs 0.4 of a kilonewton per square meter. So that gives our total permanent load at 1.31 kilonewtons a meter, and our variable at 0.9. Now that's the information effectively we're going to plug into Eurobeam. Okay, we're going to jump straight onto the data entry screen for Eurobeam. The previous video identifies how to get to this level. It's intuitive, but if you forgot, then you'll need to go back over the first video to ascertain that. But this is the first data entry sheet that's relevant, and this defines the loads, and that's quite aptly shown in the toolbar above. It says loads, so we put the loads into this particular data entry sheet, and then all the information in relation to the timber goes into the timber, and it's as simple as that. How hard can that be? Right, okay, we're in the load data entry sheet. Top part is just the beam, which is just the reference, so I've just put in there floor joist with partition load. Span, clear span's 3.8 and the effective span is 3.9. Centre to centre or clear plus 100 if we're talking about cavity walls, and we bearing on the inside leaf. Beam type is timber. That auto own weight, really you ought to get rid. Well, it's relevant for steel beams. It's not relevant for timber beams because, like I've said before, we've already taken that into account. So basically, we're just checking the spreadsheet for the loads. So down the left-hand side column, the T column, that's what identifies the load. So everything we're going to be dealing with is uniformly distributed. So that's got a U. And down the second column, which is the description of the loads, then G is permanent loads and QA is variable loads. So the first load we're going to put in is the permanent load, the 1.31 kilonewtons a metre. And so we give it the description permanent and enter 1.31 and W1. The second row, U for the uniformly distributed load, QA for the variable load, and we insert 0.9 there. And then we go down and we press the apply button, and the numbers will start generating in the left-hand side screen. Speak of the devil, there is the left-hand side screen. But before we get to that point, we have got to input the data into the timber load data sheet, or not load data sheet, the timber data sheet. So the top side is dimensions, and there's a pull down menu there for overall width, and there is a preset two number 50s. You could if it was two number 63s for argument's sake, because you were going to use 200 by 63 joists. In there you would just have to put 126 because there is no 2 times 63. There's a 2 times 47. And there is a 2 times 50. There is no 3 times, so again, if you needed treble joist, you'd have to put in 141 for 3 number 47s and 150 for 3 number 50s. And then the depth, you can either put the depth in, or you can select the question mark, and it will calculate it for you. Move along to the next column, the next moving left to right, top to bottom. So now we've got which strength class, C16, C24. We move along again where it says loading duration. Now I put long term in there because the majority of the load is dead load, so it's a long term load. If it was completely dead load, if it was just carrying, there was no flow load on it at all, I would probably put permanent, but I would define that as long term. The service class is, we put dry and heated. I've said it's a half-hour fire flow over a garage, so the garage must be heated now that I've ticked that. It's too late to go back. Move across left to right again, flitch beam, it's not a flitch beam. There is no load sharing, which is contrary to the super beam. Super beam would give you the option for 2 members to share the load. But load sharing for Eurobeam is ceiling joist, floor joist, 4 or more members supporting a common load. And that's it. Do that and press apply. And in this particular case, up comes two number 50 by 200 C24s, and they are okay. Start off with a blank screen. That's what we generally do. Open up Eurobeam. My desktop icon has disappeared. God knows where that's gone. Another computer idiosyncrasy. Put your initials in. Sign your life away. Start a new project. 36 of the street. Badly typed out on that. There's double joist. Okey-dokey that. Call that DJ for double joist. So that's where it's going to dump the file in documents. Replace the existing file, yes. And now we add a beam. It's going to be timber beam. It's already identified something. The right hand side. So we want to. This is the load data sheet, data entry sheet. Like I said before on the PowerPoint. Then we have the timber, and we don't worry about the bearings too much because that's more for steel. But we'll type in double joist. Badly again. The span is 3.8 clear, which is 3.9 effective. The load configuration goes in the T. Don't know what the hell T stands for, but that's where it goes. And like I said before, we're only dealing with uniformly distributed load, so that's U. G is for permanent load. So we'll put permanent. And if we nick onto our spreadsheet tells us total permanent 1.31. So we stick 1.31 in there. And then we U again. And remember the variable is QA. We'll put a variable in there. Get you into good habits. And what was the thing on there? And the variable is 0.09. So that's it done. Apply, and things will happen in this side. So it's automatically thrown up a 300 by 50. That must be the default size. But we've done everything we need to do in the loads. We've got the span and the load. So now we go into the timber. We'll start from the left to right, top to bottom. So if we go overall width, and we've got two number 50s in here. Now we could quite easily type in 100 in there rather than use this. And of course there's no 63s in there. There's two number 63s. There's not two number 75s. So under those circumstances you would just type in whatever the width is. So if you were using two 63s, you would use 126 in there and not worry about this. But we'll use that. And we'll put 200 in. That's what we're looking at. Hopefully it's going to work. Move along. C16, no, we're going to use C24s. Loading duration. The majority of the load is permanent. So I'm going to put a long-term load on there. If it was all permanent load, then I would stick permanent. Because there's a little bit of variation in there, we'll stick long-term in. And the service class is dry and heated. Apparently we have a heated garage, so it must be a really high class job. Flitch beam, it's not a flitch beam. This has the opportunity of putting plates in and designing the flitch beam. So it's a super little piece of a super application. Load sharing, there's no load sharing. This is purely for load sharing is purely for, or the way I'm looking at it is purely for where there's more than 4 members sharing a common load, i.e. floor joist, ceiling joist, rafters. that kind of thing. But if we just got a couple of timbers added together, I'm not using that. So we can now apply that, and up she comes. So according to this, everything is fine. And because now I have a real copy of Eurobeam, I can now print it out, send it a PDF, OK it. It just might pop it up, I don't know. So obviously there's lots of things you can do with a printout, but the demo version is great to learn on. So but there's all the loads, the reaction, the unfactored, then the factored. Those are the factored reactions. We might talk about factoring later, but these programs do all the factoring for you. There's a 2 8 per 2s, 200 per 50s. Grade bearing, shear strength. That's basically what you're allowed. Now C24 just means that the grade bending strength is 24 newtons per millimetre squared. If it had been a C16, that would have been 16 millimetres. These are high in comparison to the British standards because the loads are factored. This is allegedly limit state. So there's the bending, shear, deflection, and everything's fine. Happy days.